with that in mind, I'm just going to say hello to everyone checking in. And my objective here, just showing this and streaming, is not so much maybe to get people interested in C3, but let people have a look at how C is quite sufficient to write a compiler, and it's actually very pleasant. So the reason why I'm writing C3, which is like an extension to C, is essentially because I think C is really good in itself. There are things that we can do today that could make it a bit better, but there's nothing wrong with the way we code today in C. The procedural way of structuring things is actually very good, and we should move away from doing too much object orientation where it's not necessary. And okay, so today I'll be working on the macros. So just a quick review. So I have this example here, and this is how sort of the macros will look eventually. This part, I'm not sure about the syntax, but it's going to be fine later on. It's like I just have to think about it many times and try it out. This is taking a trailing body to a macro. I won't talk about that now, but what I did recently is like I started doing first a macro. Obviously that takes just a value. So you can like have a value, and it's just going to do anything, something like if it's just going to return value, then it's basically the macro foo. Like if I do say like x is foo1, then that will actually compile to just this thing, right? So if I put a here, then it will actually first create like a temporary, like if a is something, so it's a temporary, and then that's going to be a, and then a, like this, right? Because it just takes the value, so that if I have something like this, then it's not going to repeat that. It's going to be like so, basic stuff. So that's the first type. But then we can have this type, and here suddenly this becomes just an expression, and it's not quite evaluated. So in this case, we'd instead have actually this with a, like that. So if I put like something like some function like this, it would actually compile to this. Again, it's like this, one is evaluated and one is not evaluated. And I can also have this type of argument like this, or value like this, and then now it's a compile time constant. So that behaves differently. Then it means that this part here has to be a compile time constant. This is okay. Obviously compiling to, yes, actually it's going to be like this, right? Because it's going to constant fold everything. And it could be like you could have some compile time constant. If I defined a compile time constant like this, just giving some background here. So it's like, a is 12. Right, so then this would be 12, so this is what would happen, this is what would fall to. And I have more types, so more ways of annotating this, and the next one, the one I'm going to implement, is this one. So this is just as if it had been this expression, but it just works like taking the reference in C++, right? So in this case, this wouldn't work this would be an error because that is not, or actually that works, sorry. That actually works because it will take the value of the reference to the temporary. But like typically maybe you want to like, if you have an int a, oh yeah, sorry, like you have this, right? And then maybe you do like a value plus plus, and then you would return that. In this case, we would get like, we would actually get a times a, but we also get, like before that, we get this type of code. So this would sort of resolve into, this part would resolve into this one. So that's what I'm going to do right now. This is not working at the moment. And we can ensure that by basically trying to compile it, and it should not work. So it should protest something. Yeah. Like in this case, we need a type name. So apparently it's not even compiling in the first place. I don't know if this first place, maybe this works. Yeah, it doesn't work. So we have to go through the parser first and make sure that the parser will accept this, and then continue. So the way it works is we'll have a quick look. Probably because I'm talking a lot, then maybe I won't have time to actually complete this. But anyway, so this is where everything is. So this belongs to the cogen. This belongs to the parsing. This belongs to the semantic process. And then I have most of the all the enums. Those are here for some reason, and then the types and stuff like that will end up in the compiler internal because it's used like all over the place. So I don't use. I started out using header files for everything, like in this case a big int here, but it's not so nice to do that. Actually, it's better just to slap it all together in a big header file because otherwise you'll like spend so much time moving functions back and forth between header files and including them, and like spending a lot of time just arranging stuff, and that's like time better spent doing something else. And this is not like C++ where you get like huge like the compile time is going to explode because of this, because here we're just pre-declaring stuff and it's not parsing any functions. All right. So I'm going to jump into the parser, and since this is an expression, I know this is in the parse expression something, or maybe it's in a. Hang on, sorry, I was wrong, because this is a top level thing, and at the top level, we're just going to. There it is. So it's in the parse global file. I like jumping around. Use Clion, C-Lion, or whatever it's supposed to be, how it's supposed to be pronounced, and just jump back and forth. This is pretty much broken on C++ because the environment has really lots of difficulties finding definitions and so on for C++ still, but C is better, but it's not perfect. Anyway, so in a top level statement could be any of these, right? So I'm just going to find where I parse the macro. So here it is. So maybe I should like put the explanation on how the macro works here. I could do like skip that. It's something like you have a macro, you have the macro. It's like the macro token, and then the maybe a type. Oops, spinning beach ball here. So maybe the type, and then an identifier. And then we have the parentheses, and then we have all the parameter declarations. Hang on, I think it's no, it's not here. So we have like a macro params. Just going to write like this, right? So, and then we have obviously a compound statement. Compound. So that's basically the definitions for macro. And so here we are parsing that maybe type, and then we're trying to get the macro name here, and then we go to the parent parenthesis, and then we consume until we have hit the right hand. So we can get a, first we maybe do the type. So so like the test type thing is oh, here it is. Right, here this should be taking this token and accept it. So I don't know why it doesn't. Since we don't only have one macro, I'm just going to step through this and see what happens. So it should be, doing stuff here. So it's in here, and then I don't know what we did. Did we have an int? Yeah. So it should be like happy. Oh, there's a type. So we go there, jump back, and then, oh, it doesn't see an and. Is that like, oh yeah, it should be like amp, right? So that's why it didn't work. I just wrote that wrong. So now actually this should probably compile. I mean, that far at least. Just run this. So yeah, what happened then? Let's see here. The expression cannot be assigned to. Okay, so we got all the way to parsing this completely. And now we're back into the semantic analysis. And then it finds like, okay, you can't assign to this expression, which is, wrong. But that's probably because I had added some annotation to that it couldn't understand. So we hit this because it doesn't think this is a null type. So just can see why it doesn't think that. So the inner expression here. So we analyze this plus plus thing. Here we're going to analyze like something like foo plus plus, foo minus minus, and also minus minus foo, and plus plus foo. All those are just there. False if analysis fails. Right. So let's see. It's an identifier, so it knows that. But why isn't it allowed as a value then? Because then it has to be an identifier. If it's an identifier, then it has a that should correspond to some declaration. Here it is, arrow value. This is the data for that one. And we see it's a ref. Is that used? Anyway, so we're going to see there's a name, there's a span, we have a type, but it also has somewhere here, this is a variable declaration, and it's a param ref, right? So that is perfect. It's supposed to work, but it doesn't work. So I'm just going to check this one. So if it's an identifier and it's one of those, then you can't assign unless this is okay too as well. So if it's a ref, then you're perfectly fine to assign to that. All right, so we passed that part. Now, so we get some error anyway. So there's something missing when we cast things to an R value at the end. So what happens is that first we did this, like it looks like this, right? So now we have something, and we have a param ref, and we need to convert that into an R value, like a value. And there is some code here to do that, and there's something missing here. There's a to do. In this case, it's actually, this should just be like a normal param, I think, because it's just okay. You can just do that. So you just need to, just break, and it should just work, I guess, because it works for those. So just gonna move those. It's just standard case. So a ref is a fine to sort of do. We're gonna hit some obstacles when we go to, I guess maybe kind of good work. So now we're hitting the cogen here, because we have something and it's not quite working. So let's see here. We're getting all the way this way. So this is like trial and error, because I don't really remember everything about the code. I know it's like sort of how it works, because I work on this on and off. But we can look at the debugger here, and we see like we are in this inside of the assign expression. So that would be like hang on, let's see if we can find that code, debug stuff, right? So we're in the assign expression, and that seems weird if you don't know that what basically happens is that we sort of create a scope here, right? And then we put this party inside. So it sort of looks like, let's do like A++ like this. If you have the GCC, then it would sort of think of it, you can think of it as doing this, right? So sort of like that, right? So that's why it's inside of when you do the gen of the assignment here, right? And then you get the unary expression, this inc, and here we get like to the problem, because we're not generating an address for this. So why aren't we creating an address for the this variable? And I think the reason is, like in the beginning, we are supposed to generate a parameter when we sort of we do the macro, when we create the macro. We're supposed to sort of make an hang on, I just have to check this. So here's the expression, the identifier, and it's totally fine. And then somewhere here it's not fine anymore. So it's a variable. Hang on, it's like takes this one, and then we do the declaref, and it has a backend ref. But the decl, so any identifier, it has like a backing declaration, right? So that's what I'm looking at now. So we have the identifier that's breaking. Here we have the value. Sorry, it's like inside of here. You get like the expression, the adder is supposed to be like taking the expression in there and then do an increment on that. And see, it's an identifier, it looks fine. And because it's an identifier, we go into the identifier expression, and then we find like the value, but that's wrong, because we should have been replacing all the identifiers of value with a. So, but maybe there's something in here, it's a var, it should be like an alias for the a. So, but I guess it's not doing that. So we have a param ref, and that's fine. But then what is the declaration actually pointing to? For that one, no. Maybe we should do that. Like, we could, if you have a ref, then it's sort of an alias, right? So that should be, possible to do. So how to explain what's happening now? Right. So I have to go back to when we do the semantic analysis of the macro. To understand a macro, you have to think like this is you will be doing a copy of the AST, and then you will want to change it a bit using the parameters, right? So given a macro call, which we have here, going through those parameters, and then I do stuff, and here's some missing to do because we're going to want to have varargs later on. And then we go through the params and we do stuff to it. So here is the reference, right? And we want to make sure that the expression is, here we take the actual address of the thing. And then we don't do much more about that. Now we have an arg, and we don't put that arg into the param, which won't ever work. So maybe like we should do something like now we have a var, and it will sort of alias another declaration, which is the arg. The arg no, that's bad. It has to go into the init expression there. The arg has to go in there. And then whenever you see a var decl param ref, this one, you have to do something funny with that. We have to, if you do like that, that's fine, right? And then if you cast it to an R value, what you actually do is that you want to take, like you want to replace the init expression with like that identifier, and then you want to make sure that you do the same analysis, like you want to cast this to an R value something, which is what's happening here actually, but we can do that recursively. So context and the to and expr, so this is what we already have there. So this is taking the R value, this is the reference, and then we have this taken address of that, and this, okay. In this case, we just skip the parameter, and then when we take the address of that one, so so this is tricky. We wanted to take that one, and then we're going to, when we have this, we want to make, create a value. This is going to misfire you. But what we have is a reference, right? We have passed in a reference. We have the declaration that it belongs to, so we can actually emit an address here, which is like gen context emit address something, emit address of the expression, the inner expression inside of that one. So it's a decl and it has a var and it has the inner expression, which basically the a or something like that. So we're going to generate when we enter the macro, which is happening here. We're going to generate the address. Then we're going to store the address as the backend ref. So we get a backend ref, right? This is going to be this address. I guess that's correct. And we don't need to store anything. We're just going to like continue here. If I'm thinking about this the right way. I wasn't. But I realize I don't have any good test cases either. So anyway, so here we go. We have the decl, and we apparently didn't assign a init expression yet, which we should have done. Let's see here. Type def generic blah blah blah. Oh. So I'm just going to check why this one isn't having a init expression. Why? That doesn't make sense. So go back here and it's something missing in the macro call. What? This is something totally unused. So we go here and we have this param ref, right? And we do set that to the param to that, I think. Don't we get here? Go here, yeah. And then we just dump and set it, right? And do we do later set it to something else maybe? Yeah. So here it's set to arg, which maybe should be fine. So that should be fine, right? So let's say we go there. And now, like, what does the param say? The param is still a ref, and it doesn't have a, the init expression is fine, right? And we go, and then we end up here. And something is doing this, and we have the decl, should be the same one here. It's var, it's, you know, it's the var we had, I think. And then, well, this is not good. Someone is messing with me. Right, so let's go here. See that it's the same one. So we go here, and this declaration is, the param is AF0. Then we continue and get here, and the declaration is what? No, something else. This is not the same thing, which is why it breaks. It's like, Oh yeah, hang on, maybe I'm copying this stuff. Still doesn't make sense. Perm is copied and it's analyzed. So here somewhere. We should just have one parameter. That parameter is value. It should have a var, and that var should have a init expression, which is this. And so far it looks good. But then at some point in time we get to this. So we get again to this group, and we have the macro block, and it has params. And I would think that these params are the same as the params that I actually assigned before. So debugging. We go here. This isn't even resolved, right? Because this doesn't make sense, because we only ever want to use parameters that we already resolved, but here we don't have any resolution on that one. And that's weird. That's super weird, actually. So, I mean, what we're doing here is we're going to get the function parameters, the one we do all this, right? We get here, we do the copy of stuff, we have the parameters, we add them as locals. Hey, I think I know. We actually don't take the params, we later on put the func params here, and that's just something else. So we want to do this. Now that makes sense. The weird thing is that it didn't break doing other stuff. Right, we can skip that one. We can skip that one as well. Boom, it actually compiled. Right, so now we want to test this. So here, presumably, I want to check what is A and what is X. And we have A and X. And then maybe we can do like foo again. And then we can print this again. Right, something like that. So I'm compiling that. Let's run that into think that and run. So here we are. So it was 2. I sort of expected it to be 2, and since it was 2, afterwards we did this. And then next time it was 3, but we didn't change X. So that looks okay. We could do stuff like, we could do other macros now. We can actually remove this. That should work as well. But if we do that seemed to work. Just the same thing. We could do a double here, and then it should probably complain. Oh, sorry. Hope you see it better now. Oh, so int cannot be implicitly cast to double. Let me see how. Right, I'm just going to move. Hang on. If I split this somehow. to bottom right. What? An event log maybe, and debugger. Let's see if I can add a few things so that the messages are put in the right place. So that was the messages. Where's the run? Darn. So maybe can I just remove myself? You know, it's a bit annoying that you can see what I do. All right, I can just move this up, of course. So the other stuff was from something else. So maybe you can see now. We got like, here's the first one. You got this one, and then I changed the code a bit. Move the camera to the right. Can I do that? Like, can I somehow edit the layout so that, yeah, I could. Right, so that was nice. So, hope that works. All right, learning things like this is the first time I use Twitch. We could, oh no, we got the errors doing this, you know, just right now. If we compile this again, we see that we get the errors because it wasn't int. You can't take a double, like if you expect the double reference. So you can't implicitly cast that. But you could if you do like, maybe you have a long here. It might work or might break. Let's test it. Yeah, you can't implicitly cast that one. Actually, that breaks in later on, you know, here when it tries to go back. So this should work. Should work. No, it's this one. So that's fine. Yeah, I made it really strict. So now that actually works. So I have these. I could do like something else here. Foo. You know, it does. It adds foo, whatever foo is. And now I could do like adds a, right? It adds itself, and now it adds x. So this is just evaluated as an expression here, or maybe a++, right? So let's just check that this works. Yeah. So what we expect from this, in this case, we start with a, we add a and then do a plus, so we get like 2 and plus makes a 3. So 3 times 3, so 9. And then next time we have a and we take, maybe do it like this. We take a and we add, in is now 3. We add x, which is 9, but we do pre-dec, so we get 8 instead. So 8 to 3, 11. So let's see if that happens or not. That was annoying getting this all the time. So we go to the terminal, like that, and get something. Ooh, this doesn't look good. Good. Let's see. Is there anyone who can figure out why this happens? Oh. Did that really get compiled? So this is super interesting. Just making sure. So, does that make sense? No, it doesn't, right? maybe I should just do something simpler and see what the output is. So I don't get the plus plus there. Oh yeah. All right. Yeah. Actually, it should be warning about this because no, that should be fine. Actually, should be totally fine. So in this case, foo adds to a, so a is 1, 2, that's okay. Right, so that's correct. Do you think about this in the wrong way? Okay, let's do a printer. So values 2 afterwards, and that makes sense to be a 4, and then the value is 5, and then we don't actually use that, right? So it's a 5, and we just decrement. So that's correct, but why doesn't this work? Oh, maybe the ordering of doing that is a bit weird, I guess. So if I do like foo first here, right, what happens then? If I do foo and then do the ordering and then see what the result is, doesn't work correctly because it should just get 16. Like if I do a lot of foos here, do they evaluate every time? They should, but yeah, they do. So this is just the fact that the way this, like if you had something like a plus equals a plus plus, the way that is evaluated would be wrong, I guess. So that is maybe undefined behavior actually. In C, I mean in C it's an undefined behavior, I think. But for this case, I wonder what happens if I do like this instead. So I have like value plus foo. I wonder if that's more like well defined. It might be. No, that gives the same thing. So it's 1, right? So it's here the value is 1, and then I have the foo which says put it to. I think that should like move it to 2, but it's going to get like into 2, and then it's going to get assigned to 2. So maybe that makes sense after all, you know, because this one actually happens before, and then you assign it. Yeah. So that should be actually okay. It's the correct answer, but I thought it was the wrong answer, but that makes sense. So so that's just that part of that just ends this functionality, I guess. We should be doing more tests for this, of course, but I'm just going to be happy about finishing here. Just macro reference arguments. So foo. So yeah, I won't be pushing this immediately. I'll wait until the whole macros are done. So later on, I'll start working on the putting in the types. So you will later on be able to do like this. So type, for example, and then you could do like type x equals something, or do something. I don't know. Maybe you can like say, okay, x size of x, right? And return that. So, but we'll do that later, some other time. And I think if this actually works with the Twitch and so on, I'll take the next one to actually demonstrate some parts of the language and explain why I am building this to begin with. There's a question here, like how do you lower reference params? I suppose you mean like in LLVM, or could you explain what you mean by that question? So in the AST, it's just treated as a variable. So I just do the checks just as if it would have been a variable. Let's go back to what it looked like, right? So, for example, I could have foo, right? So the difference here is, in this case, what would happen is that we would evaluate this one first, right? Yeah. So for the non-reference, I create a temporary for this one, right? And in the other case, what I do is I basically set the initialize, like the expression here just goes into like the temporaries init expression, but I do some special handling for that. Let me go back and show you. So this is actually a bit gnarly, and because of how it works with declaration and so on, I just happen to have this init expression handy, and maybe I shouldn't have done that. But so let me just write some code here and try to explain this. So for the normal references, like the normal non-references, like you said, that's correct. I have like this foo taking a, no, I have to, let me just remove this one. So we have the value, right? If you have foo and it wouldn't have been a value, like say it's something foo return u times value. If it had been basically this, then we would do like the temp equals whatever was the value, and then we do temp like return value is temp times temp, and then assign it to whatever the variable was. So like long x equals this return value. That is expansion if it had been like a value. But now we wanted to have a reference. Maybe we do something funny, like we do like this first, right? So we have, if we have like this, then this code would have been, would have added a temp plus plus, right? So that should make sense, like this. So this would have happened. But here, when we do like this, I like basically say that we have a temp which is sort of A. Not really, but basically say I have temp is A. And when I get to temp, I'm going to replace that with A. And then I get to temp, I'm going to replace that with A. And this one, I'm going to replace that with A. So it's sort of hackish there. Yeah, they are hygienic. I was thinking about making opt-out of hygiene, but then in that case it would be like basically you would have to specify that. So I don't remember what the syntax was for that, but basically saying something. Hang on, I was just going to switch to another window here, see if I had some. I wrote that down somewhere. Maybe that was in one of my ID things. So so I don't remember the exact thing, but it was something like you could specify with something that, okay, let's try to capture that or export it out of this scope. And then it would not be hygienic, but you had to explicitly do that and name that parameter. But that's not um, in the system right now. But maybe it will end up in C3. I haven't decided yet. So a ref, yeah, it's an expression, but actually it's actually evaluated. So I just have to like add this thing because we could have done like we could have said, okay, let's do foo of some function. So we have like a function that returns. We have another function bar that actually returns like something like this. So like we have a function that takes, which is bar, which takes something like that. So bar does something, and in here this would be an L value, right? Because this is the this part here is an L value. So in that case, it would basically put in here. It would put this part, right? Already, like it would be more of a. It would not evaluate bar more than once, right? So because it's still an expression. So you would not you'd like basically do something like we have temp another temp, which would evaluate bar this part this bar, and then you would take that temp and you basically have like something like temp2, right? So so you had like temp2 everywhere. Like, temp2. That should work. I haven't tested it right now, but it should work. So let's do that, maybe. We could have like an int x which takes this. So this should be fine. Oh, sorry, x again. Man, too many x's. So like this should be fine. Let's see if that works. Oh, there's another foo here. I have to skip that one. Ooh, long. Ooh, we didn't handle that one. Somehow. We have that and we want to cast that to an R value. And we did copy that one from the macro. We get in this place here and we have an expression, and the expression is a deref, right? Yeah, this is the unit. This one, right? It's the one we had, and it should already be evaluated. Oh, it assumes it's a declaration. Yeah, because man, so cast, there's like this ident R value, but that's not the one we want to use. We want to use the cast R value. And that one, this is, the problem here is this one is declared here, and I guess this is like the downside of using let's see how to do that. So I think this should work now. That's good. I could fix that as well. So let's run this now. I think that will work. Yeah, so we get 2, 4. So that was the expected one, and I'm just going to then append to that to make that commit. Thanks. So is there some other question, or I was thinking that I'd end the stream right now. It's 10 o'clock here, so time to go to bed. Thank you all for watching, and I'll upload this on, try to upload it on YouTube. Bye.